reflection, and all these things have completed, right? So now let us talk about the next topic, which is beats. Right? So in the last part, what did we talk about? Last part we talked about that whenever we have two kinds of waves, so the overall displacement would be calculated using superposition, right? So superposition just simply says that it would be just the addition, algebraic sum of all those integrations, right? So if we have more than two waves, so the total displacement would be just the sum of all these, right? So we will use this principle to solve this beats and standing beats. Let us quickly start this. So what are beats, right? So this is, as the name suggests, right? We have heard about these beats, music, and all these other instruments, right? We have already understood about these beats. So these beats are the superposition of sound, right? But there is certain condition that has to be followed. So we'll talk about those conditions. Right? So what are beats? Beats are superposition of sound waves. And this is what this is. It is the periodic motion of the amplitude of two sound waves which have same amplitude but different frequency, right? So this is the idea of waves moving in the same direction, moving in the same direction. So and their phase difference is also used. There is no phase difference between right. So let us talk about these beats, but there are certain conditions, right? Condition for beats. First is that they have same amplitude, and same direction. Second is that the frequency difference between the sound waves should be less than 10 hertz. Right, so this should be, so the difference between the frequency should not be that much large, right? So this is how we get the gain. So let's take the example, figuratively let us make that diagram, and then it would be more clear, right? So let's say we have, this is one wave, and then we have another wave, right? And then they superimpose, and then what would be the wave? So let's say we have one wave which is traveling like, this is one wave. And then we have another. So the same height, let's say this is A. At the same height, we have another wave, right? So these are the two waves. And you can see that both have the same height, right? Both have the same height. And can you tell me that which one has the greater wavelength? What is the wavelength of this one? So the wavelength of this one is from here to here.
First one.
Yeah. So this one has the greater wavelength, right? Because this one has this wavelength and this one has this wavelength. So wavelength is
Yeah.
the distance between the two crests or between two troughs. Right? So this is this distance. And we can also calculate the wavelength from the origin as well, right? So whenever the wave repeats itself, so that would be the wave. Right? So this is one. So this has lambda one wavelength and this has this wave from here to here. This has lambda two. Here to here, this is one wavelength. From here to here, this is another. So you can see that both have different wavelengths, right? But their amplitude is the same, and they are moving in same direction, right? So then,
Yes, sir.
then the resultant amplitude or resultant variation of the waves would be like when they superimpose. So this would be right. So let's see, starting from that time. Uh, And let me. Type. This is how the beats will fall, right? So in here, this would be maximum, and this is your right. So your amplitude is my minimum at this point, and amplitude is maximum at this point. So this is the superimposition. So this is the variation of beats, and you can see that the amplitude is changed, right? Amplitude is varying. For this one, the amplitude is fixed, right? For this one, the amplitude is fixed, but for this one, the amplitude is large and then it is decreasing and then it is increasing. So this is how the bass vary, right? And now let us talk about superposition of waves. So let's say one wave is AKX sine KX minus omega t, right? And let's say that it has, so let us write it as omega t minus k. And we can write omega, let's say this is, and then the other way is because the amplitude should be same, sine, and let's say this is k. is omega 2. Right. So this is these are the two waves, and we know that their frequencies are different, right? And how can we write? How can we write the frequencies with the form of omega? How can we write the frequency in terms of omega? What is the frequency? Yes. What would be the frequency?
Omega 1 t minus k1 minus 6.
No. So this is angular frequency. Then frequency is 2 pi nu or 2 pi f. This is how you write the frequency, right? Omega is equal to 2 pi nu, right?
Yes, sir.
This is how you will write. So let's say we can write y1 as a sine, and this is how much 2 pi, and nu1 t minus k1x, and then we have y2, which is a sine pi, and the other frequency is nu2 minus k2. It's these are so the overall wavelength would be, or the overall wave would be how much? That would be y1 plus y2, right? And for simplicity, we take, because beats only varies with respect to time, right? So this only varies with respect to time. So we write it in terms of time, right? And then we ignore this x part. So for simplicity, we take x equals to 0. So then y1 would be how much? Y1 would be simply a sine pi q1t, and this would be simply a sine 2 pi, right? Because we have considered this part to be. Is it clear?
Yes, sir.
So this is what we get for from superposition principle, right? This is the superposition, and we see that both the waves are moving in same direction but with a different frequency, right? So these are the two waves. Amplitude is same. Both have the highest point. Both have the same highest. So amplitude is same for both the waves. Now, if we calculate this part, so this would be how much? This would be a, and we can take common. So this is sine of pi one t plus sine of pi, right? And
Sir, can you take sine also common?
which common?
Sine.
Sine. Oh, so this is not multiplication, right? Can you write sine 30 plus sine 60 as sine 30 plus 60? Can you write that? Yeah, can you do
No.
that? This is not multiplication, right? This is not multiplication because
Okay,
the
sir.
sine, yeah, this is sine 90. Sine 90 is 1. Sine 30 is half. Sine 60 is root 3 by 2. So this would be 1 plus root 3 by 2. This is 1 root 3 is how much? 1.7. So this would be 2.732 divided by 2. So this is not 1, right?
Yes,
So
sir.
this is not multiplication.
Okay, sir.
This is a function, right? Right. This is a this as fx plus y, right? Because f is a function. You cannot take it common. This is not multiplication function. Okay, now we have to figure out What is this relation? This is sine A. Let me write it because A is already there. This is sine C plus sine D. What is the formula for sine C plus sine D? Do you remember? What is this? What is this thing? Yes. What is this thing? Yeah. So whenever you have same thing, sine C plus sine D. So remember that what is
2 sine
sine? Yes.
C plus D by 2
C plus D by 2
and C minus D by 2
again sine
cos.
cos cos C minus D by 2. Absolutely correct. Good. So yeah, we can check this thing in here, right? So what would be cos C plus D by what would be that? This would be cos. This would be cos of C by 2, right? Into sine of C by 2 and minus cos of D by 2 and sine of D by 2, right? So that is cos A plus B.
Yes, sir.
And what would be sine C plus D? This is how much? This
Sine
is
C by 2
oh, this is cos, right? Cos and this is the sine, right? Because for cos all the this is sine. Yeah, this would be how much? This would be sine
sine
C
C by
by 2
2
and into cos D by 2 plus this would be sine D by 2 and cos C by 2, right? Because what is
Yes.
cos A plus B? Cos A plus B is cos A into cos B minus sine A into sine B. Similarly, sine A plus B is how much? That is sine A cos B and plus cos A sine. Right? So remembering these things, we can get. Okay, so now we have to multiply these two things. If we multiply these two things, what would be that? So this is multiplied, right? And we have to find out 2 and cos C plus D by 2. So C minus D we have to write because C minus D minus minus D by 2 would be that because we are just checking. I know you are correct, but we are just checking that what would be that. So this is the sine plus D by 2, right? So if we multiply that, that would be how much? That would be 2. And cos of C by 2, cos of D by 2, and then sine C by 2, and sine D by 2, and then multiplication of sine C by 2, cos D by 2, and plus sine D by 2, and cos C by 2. So much is and this is cos C by 2, cos D by 2, sine C by 2, and cos D, right? This is this thing, right? and then sine d by 2 and cos c by 2. And then what do we have? We have sine d by 2, sine d by 2, sine d by 2, and then sine c by 2, and then cos d by 2. Plus we have sine by 2, by 2, and then cos c by 2. So this long term we have. So this is 2 cos c by 2 and sine c by 2. How much would be that? So if we take this 2 inside, this 2 is inside, this 2 is inside, this 2 is inside, this 2 is inside. So we know that sine 2 theta, that is 2 sine theta cos theta, right?
Yes, sir.
So so 2 cos c by 2 sine c by 2, that would be how much? Sine c, right? This one and this one. And then we have cos square d by 2. Okay, so this is there. Plus 2 cos c by 2 and 2 cos c by 2. So 2 cos t by 2 sine d by 2. So that is sine right. Cos d by 2 sine d by 2, that is sine d. And then we have cos square by 2. And then plus we have what? 2 sine c by 2 sine c by 2 sine d by 2 cos d by 2. So again, this is sine square c by 2. And we have what? We have sine, right? Plus we have this is 2 sine c by 2 cos c by 2. So that is sine c. And then sine d by 2 sine d by 2 is sine square d by 2. Okay, so sine C, sine, oh, this is very sine C. So sine C, sine C. If we take sine C common, so this would be cos square d by 2 plus sine square d by 2. If we take from here and here, if we take sine d common, so that would be how much? Cos square c by 2 plus sine square c by 2. How much is this thing and this thing? How much is this thing? Sine square theta plus cos square theta. How much is that? Yes,
Tan.
sine square theta plus cos square theta. How much is this? This is 1, right? This is the identity. Sine
Yes, sir.
square, sine square theta plus cos square theta. So this would be 1. This is 1. So this would be how much? Sine c plus sine t. So that is what you have told me, right? Sine c plus sine d would be this thing. We should have used this directly, but yeah, why did I use that? So yeah, that is how we get this, right? Okay, so this is this thing. So we will get what? We will get this is sine c plus sine d. So as you have told me, we will get cos and c. So 2 pi mu 1 d minus pi mu 2 d by 2. So this is c minus d by 2. And then sine pi mu 1 d plus 2 pi d by 2. Right. So this would be the answer. Then if we write it correctly, this would be how much? This would be, oh, there is this 2 also. So this would be 2a and cos. And I can take 2 pi common from here. So 2 pi. And this is nu 1 minus nu 2 y2 and this 2 will cancel. and then we have again 2 again will common, and then we'll write pi by 2 and u1 plus u. So again this will be cancelled. What we'll get? The final answer would be a cos pi u1 minus let me write it u2 t and sine pi u1 plus u2. Right. So this is the effective wave that we are getting. Right. Right, Amna.
Yes, sir.
So what are the periodic parts? One is this cos one, and the other one is this sine one. Right. There are two periodic variations. One is this one. The other one is this one. Right. So
Yes.
this part is the so this part is the phase part, right? This contributes in phase, and this part contributes in amplitude, right? So this is where our nodes, anti-nodes, and the minima, maxima, and all those things, right? So this part contributes to the amplitude, right? This part will contribute to the maxima and the overall amplitude. New amplitude would be how much? This is 2a and cos of pi nu1 minus nu2 and right. This is the new amplitude. So we see that when this amplitude would be maximum, when this amplitude would be maximum, when this amplitude would be maximum, so this part would be the plus or minus 1, right? So this is the amplitude, right? So this is the amplitude. So in here and in here, this is the highest length, right? This is A and this is minus. So this part is highest part, right? So in here the amplitude would be maximum, right? In here the amplitude would be 0. So these two parts we have to check. So this part is called antinodes and this part is called. So we'll talk about in the standing wave. But yeah, then here this is maximum, and in here this is right. So
Yes, sir.
for maximum case, this cos part would be how much? This cos pi mu1 minus mu2 and this t, that should be plus minus, right?
Yes, sir.
So whenever when is cos plus or minus one? When cos is plus or minus? When cos is plus or minus?
Maximum it should be plus.
Yeah. So for minimum case also, right? This is also we are counting at as wave are adding up, right? They are adding
Yes.
up in the negative direction. So whenever I am saying maxima or minimum, so what I mean is that this is my minimum, right? Because both these are contributing to the maximum part, right? So this is going in the below part, this maxima is in the below. So whenever I'm saying minima, so I'm saying that in the context of this zero part, right? Actually, yeah. So this is the minimum case. You are right. But for this beats case, whenever the beats are going zero, amplitude is going 0, so that we call it as minimum, right? Yeah, so for waves, for oscillation, this is the minima, but this is also adding up, right? So this is the beats wave. So this is the whole maxima part, right? This
Yes,
part
sir.
is maximum, right? So this is why we write -1. This part, 0 part, we call it minimum. Okay. So when cos is plus or -1, cos 0 is 1, right? Cos pi, that is -1. Again, cos 2 pi, that is 1. Cos 3 pi, that is -1. So for these cases, whenever cos is n pi, right? So whenever cos is n pi, cos is n pi, then it is 0, pi, and 1 and -1, right? Where n is 0 and pi and 2 pi and 3 pi. Right. So whenever the cos value is that, then so whenever n is 0, 1, 2, n is 0. Because if we put n equals to 0, so that would be cos 0. Cos 0 is 1. Whenever you put n equals to 1, so cos pi is -1. Right? Is it clear?
Yes, sir.
So when you compare these two values, so what would be the value that you will get? What would be the value that you will get when you compare these things? Yeah. So you see that this cos function and this function, they are equal. So which means that their arguments, that would also be equal, right? So which means that by u1 minus u2 t, that would be equal to n pi. Here.
Yes, sir.
So then this would be how much? This would be nu1 minus nu2, and we call this as beats frequency. So that would be pi will cancel, and this would be n by t. Right. So this frequency is simply this beats frequency is simply nu, and this is the n by t. This is how we calculate the beat frequency for magazine. Okay, clear.
Yes, sir.
And for this thing, right? So for amplitudes to be minimum, right? You have what do you have? You have cos phi and minus 1 t, and that is equal to 0, right? Whenever you have this thing, it is 0, so your amplitude would be 0. So then what is this thing? Cos phi and nu minus nu1 t. And for what value your this thing is 0, cos value is 0. So cos pi by 2, that is 0. Cos 3 pi by 2, that is 0. Cos 5 pi by 2, that is 0. Right? So odd multiples of 90. So you can represent this as cos n plus 1 by 2 and pi. So you can write it like this. Right. So this would give you 0. So we can write this as cos 2n plus 1 by 2 pi, or I can write it as 2n plus 1 pi by 2. And if we compare these things, so this would be how much? Pi mu1 minus mu t. And this is n plus 1 pi by 2, where n goes from 0, 1 to n. Right. So then if we cancel this thing out, so beats frequency would be how much? Minus nu, that would be 2n plus 1 by 2. So this is the beats frequency per beat. Right. And this is beats frequency for maximum, the maximum amplitude. Right. So these are the things that you have. So let's say that if we are right, so let's say we are calculating the minimum, right? So first maximum, right? The first maximum would happen at, let's say, n equal to 0. If you put n equal to 0, so nu equal to 0, right? That would be the first maxima. And if you put n equal to 1, so at 1 by 2, there would be another frequency. So these are the frequencies, right? So is it clear to you?
Yes, sir.
Then please write it down. Beats are the superposition of sound waves, but the important condition is that their amplitude, their peak should be same, and they are traveling in the same direction, right? But they have different, slightly different frequencies. These are the conditions. Right? So please note it down, and then we'll talk about standing waves. Right? Let me just. Yeah. So just superposition of sound waves, right? Yeah, whenever you want me to scroll down, please do.
Done, sir.
This graph is right. In the NCRT book, yeah, it is drawn in a very right beautiful way, but my drawing is very bad. Okay, so remember, this is right. So this amplitude would be because this is A and A. So this amplitude is remember it would be right or the whole amplitude that would be here. And this is flowing in the time. So what would be these times? These times we can also calculate. Calculated frequencies, but we can also calculate the times. I will talk about that time as well. Whenever you have noted, please,
Done, sir.
done. Okay, then uh, down. Yeah, whenever you have noted, Yeah, believe you have written it down. Okay.
Done, sir.
Yeah. Okay, then note down the parts. Okay, so you have to calculate, right? In this part, you have to calculate the timestamps where this maximum is happening. So you have to calculate the time, right? Because you would be given the two frequencies and then you have to calculate the time. So time would be n by, which is n by, right? Where this, so this would be the time for maximum amplitude, right? And then you will have some time. Then you can also calculate the time for the minimum amplitude. You have to calculate the time because frequencies would be given. This would be the time for the minimum amplitude. So let's say for first one, that would be 1 by 2 V1 minus, right? Please,
Done, sir.
yeah. Okay, so whenever they tell you to calculate the time for the minimum amplitude, right? So for maximum one, uh, time for maximum one is what? That is n by v1 minus v1 minus u. And time for the minimum one is n plus 1 by 1 minus. So if we want to calculate the first maxima, the first maxima would be 0, right, at 0 second, and then the next one would be 1 by v1 minus v2, and then next would be 2 by v1 minus v2. So this would be the maximum, right? So let's say you have this beats. One would happen at 0, right? So at 0, 1 maximum is happening. At 0, 1 maximum is happening, and then it is going down. So this is first one, right? This is t equal to 0, and then the next one is at t equal to right. This is next, right? This is t equal to 1 by nu 1 minus, and then this is the minimum, right? So this is minimum, this is maximum, this is the maximum, and this is again minimum. So this second maximum is happening at this one. The third one is happening at 2, 1 minus. And the minimums are happening at, let's say this is 1 by 2, 1 minus. This is happening at 1 by 2, mu 1 minus mu 2. And then the second one is happening at plus 1. So 3 by 2, 1 minus, and so on. So this is at 3 by 2, 1 minus. Please note it down, right? So whenever they ask you that what would be the time for the maxima, so this is the time for the maxima, this is the first maxima, second, third, then this is the first minima, second minima, and so on. Quickly note it down, and then we will talk about the standing waves. How the waves are. Yeah, whenever you have noted, please so this is for maxima, right?
Done, sir.
Okay, so the next topic is standing. Next one is standing. So what are standing waves? Right, it is again based on superposition waves. So based on of wave. But for this condition, right, for this condition, what is happening? is that the amplitude is same, frequency is also the same, but the two waves are moving in opposite direction, right? So let's say let's say you have a traveling wave, right? So you have a traveling wave, so how much far it can go? So it is indefinite, right? Indefinite, the energy can go. So wave is about what? What was the idea of wave? Yeah. What was the idea of wave? What were waves? Amna, what were waves? Waves were meant to transfer the energy, right?
Yes, sir.
Waves were means to transfer the energy, but we can transfer the energy from indefinite distance, right? From infinity to other infinity, we can transfer the energy. But if somehow we confine that transfer of energy in particular boundary, so that is called the standing waves, right? So those waves in which the transfer of energy is taking place between some boundaries, so that would be called standing waves, right? So let's say this is a wave which is traveling, right? So this end is infinity, this end is infinity. But we confine this wave boundary. So this will the one wave and then the other is the reflected wave. So one reflected wave is coming. So then you get then you will get a wave which will be confined in this boundary. So that is the idea of standing waves, right? Standing waves, you get the waves which are confined in a boundary, and we'll see what kind of boundary we take. So that is the idea of waves. This is it is the superposition of two waves in the which are having which have same amplitude, frequency, and velocity, but are in the opposite direction. Right. So this is the idea of standing. So they have said in the beats, their frequencies were different, right? But what was the direction of those two beats? What was the direction of two sound waves? What was the direction? Yeah, what was the direction of two waves in beats, sound waves?
Positive.
Direction was same, right? Yeah, positive or negative whenever they are moving in same direction. So in that case, the waves had the same direction. Look at this thing, right? So this one had the same propagation direction, omega t minus kx, so positive x direction, omega t2 minus k2x, positive direction. Both had positive x direction, same direction, right? So both had same direction.
Yes, sir.
But in the sound wave, we will have opposite direction, but their frequency would be same, right? In the beats, frequency was different. In the standing waves, frequency is similar, amplitude is same, velocity is same, but they are moving in opposite direction. So this is what about the waves, and the standing waves will create standing waves mods and anti. And so this is generally represented by A and this is represented by right. So nodes are places where the displacement of particle is and antinodes antinodes are those where the displacement of particle is the maximum. Right. And figuratively, how do we represent that? So let's say we have this confining wall, right? This confining wall, and let's say we have this way which is, and then this way which is, right? So in here, you see the displacement is maximum. So these are anti-knots, and this one, these are the knots, right? And this one, so these are anti here. So in here, the displacement of the particle is maximum, and here the displacement is so where the displacement is maximum, anti-knots minimum zero, that is. And again, the other peculiar property is that the energy of the particle is confined within boundary. Right, so no energy is going out of this boundary. So the energy of the wave or the particle, energy of the wave is confined within the boundary. And at antinauts, at antinauts, all the energy is converted potential energy and at nodes, all the energy converted kinetic. These are the important points of the standing wave, and finally, the separation between consecutive knots or anti-knots, lambda. So these are the important points of standing waves. right? So please note it down, and then we'll understand it even. We just will have to remember that two waves, they are superimposing, but they are in opposite direction. Please note it down, and then this chapter will be. So in the next week, all of your syllabus will be. And in the meanwhile, you start your preparation, right? So continue with your preparation.
Sir, why no one is joining?
Yes.
Why no one is joining the class?
Yeah, because Ilham is facing some serious issues with her. It is a very sad and unfortunate news, but yeah, Ilham's family met up with some accident, and she is happening with her emotionally, but she's not in the emotionally she's not in the condition to join. And, Rishita is not joining her exam is happening, so that's why. And she will join she will join us, right? Yeah, that is why what is yeah, just pray for Ilham's family, right?
Yes, sir.
And I also didn't talk to her because yeah, she was not right. Okay, whenever you want me to scroll down the screen, yeah, whenever you want me to scroll down the screen, that,
Done, sir.
yeah, okay, so then that works.
Done, sir.
Okay, so now let us see this by an example. One example that we can take is one example is standing wave in a string. In a string, right? So we already got that what is the transverse wave for the string waves, right? We already got that what was the incident wave. So incident wave was a sine omega t minus. Now we have this boundary, rigid boundary. So what would be the other wave then? What would be the other wave? This is getting reflected by the rigid boundary. So from this boundary, you will get another wave, right? So this is the reflected this is the incident wave. And if you remember, what was the direction, right? Yeah. Yes, Amna, you got disconnected, right? So
Yes,
this
sir.
is the reflected wave, right? This is the reflected wave, and this is the incident wave. So now we have to calculate this summation of the exact, right? And okay, so you note down the and then the calculation. You just note down these parts, and now we have that's why because both the same amplitude, but same frequency and everything same. They are just moving in the opposite direction. These are we have to calculate this thing, and then we'll see that what would be nodes, what would be anti-nodes, and all the other things things we have to calculate. Yeah, please note down this part. We'll stop at here and the next part. Okay, note it down. Yeah, noted. Huh?
1 minute, sir.
and then you try to. So I will give you a homework. Try to solve this part. Right. So you have two equations about them as well. What you try to solve this shift. Right. What would be final? That will this would be this. We have to solve this, right? Try to
Okay, sir. Done, sir.
done. Okay, so Allah Hafiz, Amna, and start your preparation. Yes, see you in class. Allah Hafiz.
Okay, sir. Allah Hafiz, sir. Thank you.
Allah Hafiz. Allah Hafiz.